from LJ Institute of Engineering and Technology. Today's session we are going to discuss about Fourier series. Let's move to our class. Hello friends, in earlier lecture we are already discussed about basic formulas for integration, which is very useful in this particular chapter. Today we are going to discuss about our new unit, that is Fourier series. First of all, what is Fourier series? Fourier series, which is infinite series such a function in terms of sine and cosine. There are various practical applications of Fourier series like as approximation theory, digital signal processing, waveforms of electrical fields, tomography, heat conduction problems, etc. Let's start with one definition of Fourier series, that is combination of Fourier and Euler formulas for the Fourier coefficient. Let f of x be a periodic function with period 2 pi defined in the interval c to c plus 2 pi. Let us assume that our function f of x can be expressed as trigonometric series. That particular series converges and its sum, which is f of x, when f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx plus bn sin nx, where a0, an and bn are real constant, also called the Fourier coefficient. Next, formula of a0, that is 1 upon pi integral c to c plus 2 pi f of x dx, that is our interval. Then an, which is also 1 upon pi integral c to c plus 2 pi f of x cos nx dx. Then bn, 1 upon pi integral c to c plus 2 pi f of x sin nx dx. We will find value of a0, an and bn. These are Fourier coefficient, and substituting these values in this particular function, that is our Fourier series, and its sum f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx plus bn sin nx. Just in the examples of Fourier series, just we find a0, an, bn and substitute the values of this particular coefficient in this equation, then we get infinite series in terms of sine and cosine term. Let's start with one example. Find the Fourier series of f of x equal to x square, where interval is 0 to 2 pi. Find the Fourier series of function x square, interval is 0 less than x less than 2 pi. Example is f of x equal to x square, where interval is 0 less than x less than 2 pi. So first of all, we will find a0, then an, then we have formula a is equal to 1 upon pi integral c to c plus 2 pi f of x dx. Here our function is x square, but c means our initial value. Range interval of initial value is 0. Then here 0. Then 0 plus 2 pi. Then we get 2 pi. That is our interval 0 to 2 pi. Then 1 upon pi integral of x square, that is x cube by 3. Then 0 to 2 pi. Then upper limit minus lower limit. Then 3 constant. Then upper limit minus lower limit, then 2 raised to 3, that is 8 pi cube by 3 pi, 1 pi which is cancel out. Then we get 8 pi square by 3, that is the value of a0. Now we find value of a, then a equal to 1 upon pi integral c to c plus 2 pi, but value of c, that is 0. Then we get 0 to 2 pi f of x cos nx dx. Then here our function is x square, then 1 upon pi 0 to 2 pi x square into cos nx dx. Now here we use Bernoulli's equation, which is already explained in earlier lecture. Then according to the Lie, here x that is indicated by u, cos that is indicated by v, because x that is algebraic term and d which is cos that is trigonometric term. Then here u and v. Then with the help of Bernoulli's equation, u as it is integral of v, that is sin nx by n minus derivative of u, that is 2x integral of v, that is minus cos nx by n square, that is the sign of formula again, plus derivative of u, that is 2 integral of v, that is what v carry forward with sign. Then this minus which is carried forward in v term, and integral of cos, that is sin nx by n cube minus derivative of u constant, that 0 into anything 0. Then here limit, that is 0 to 2 pi. In this formula we must be carry forward this sign in next bracket, means sin of v that is carried forward in v term, sin of u that is carried forward in u term. Now just simplify this bracket, then we go for upper limit and lower limit, then minus minus plus, then here x square into sin nx upon n minus minus plus 2x cos nx upon n square minus 2 sin nx upon n cube, and upper limit is 0 to 2 pi. Then upper limit minus lower limit. Then here substitute x as a 2 pi. Then sin, replace x as a 2 pi. Then sin 2n pi, which is 0, which is already discussed in earlier lecture, and cos 2n pi, that is 1, cos 0 1, and sin 0 0. Then substitute this value, then 2 pi, so sin 2n pi 0, 0 into anything 0, plus 2 into 2 pi cos 2n pi 1 minus sin 2n pi 0, upper limit minus lower limit, replace x as a 0, then 0 into anything 0, 0 into anything 0, sin 0 0, then we get 1 upon pi, 2 is 4 pi by n square, pi cancel, then we get value of a equal to 4 by n square. Similarly, we can find for the Bn. Then Bn equal to 1 upon pi integral. Formula is c to c plus 2 pi. Then here 0 to 2 pi f of x sin nx dx. Then here function is 0 to 2 pi x square into sin nx dx. Then according to the Lie, similarly this term which is indicated by u and this term which is indicated by v, then UE rule. So u as it is, that is Bernoulli's equation. U as it is, integral of v, that is minus cos nx by n minus, that is the sign of formula, derivative of u, then derivative of x square, that is 2x, integral of v term, that is minus sin nx by n square. We must carry forward this sign in v term, plus derivative of this, then 2 integral of this minus plus cos nx by n cube. Then derivative of 2 is constant, that is 0. 0 into anything 0. Then here limit, that is 0 to 2 pi. Now simplify this term. Then 1 upon pi minus x square cos nx by n minus plus 2x sin nx by n square plus 2 cos nx by n cube. Here 0 to 2 pi. You can also use integrating by parts, but we suppose use integrating by parts, the length of example may be very less and maximum mistake can be occurred at that particular equations. That's why we using Bernoulli's equation to simplify this example, and length of example can be reduced for using the Bernoulli's equation. Getting? Now upper limit minus lower limit, and here 1 upon pi, here minus 2 pi square. Replace x as a 2 pi, then 2n pi, then cos 2n pi, that is 1, then 1 upon n, sin 2n pi, that is 0, cos 2n pi, that is 1, then 2 by n cube. Upper limit minus lower limit, 0 into anything 0, 0 into anything 0, and cos 0, that is 1, then 2 by n. Now expand these brackets, then we get 1 upon pi minus 4 pi square by n plus 2 by n cube minus 2 by n cube. This term are cancel out. Here pi which is also cancel out, that is 4 pi. Then we get Bn equal to minus 4 pi by n. Now our final Fourier series is Fourier series is that f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx plus bn sin nx. Now substitute the Fourier coefficient a0, an and bn in this equation. Then value of a0, that is 8 pi square by 3 into 2 plus summation n equal to 1 to infinite. Value of n, that is 4 by n square cos nx. Value of bn, that is minus 4 pi by n square sin nx. Here 2 4s are, then we get 4 pi square by 3 plus summation n equal to 1 to infinite. Here may be n square common, then 4 4 which is also common, then 4 pi n square cos nx minus pi sin nx. In this example, we just find a0, an and bn and substituting the values of a0, an, bn in this Fourier series trigonometric equations. Next example is find the Fourier series of f(x12) pi minus x by 2 whole square where range of x that is 0 less than x less than 2 pi. Then first of all we find a0. Then a0 equal to 1 upon pi integral 0 to 2 pi. Actually limit is c to c plus 2 pi, but initial value of c that is 0. Then we can directly write 2 pi, 0 to 2 pi whole square dx. Then 2 to the 4, then 1 upon 4 pi that is constant, 0 to 2 pi, then pi minus x whole square dx. Then integral of that term means pi minus x cubed by 3, here 0 to 2 pi. But whatever the coefficient which is multiplied with x, that is denominator portion in integration. Then here minus sign is present. Maximum students are making mistake at that particular sign. That's why you cannot get the answer of a0. Remember these things. Then upper limit minus lower limit 3. Then minus 1 upon 12 pi. Then pi minus 2 pi cube minus pi minus 0 cube, that is upper limit minus lower limit, means replace x as a 2 pi and replace x as a 0. Then minus 1 upon 12 pi, pi minus 2, that is minus pi, then minus pi cube, here also minus pi cube, minus minus common and plus, then 1 upon 12 pi, here 2 pi cube, then 2 6 pi cancel, that is pi square by 6, that is value of a0. Now next one is an. An equal to integral 1 upon pi 0 to 2 pi pi minus x square by 2 into cos nx dx. Then we can say that pi minus 2 square, that is 4, and 4 constant outside the brackets, then pi minus whole square, that is our u and that is our v. Then with the help of Bernoulli's equation and multiplication rule for the integration, then u as it is, that is pi minus x whole square integral of v, that is sin nx by n minus derivative of this, and it is the sign of formula, then 2 pi minus x power both side, then pi minus x into minus 1 and integral of this term, that is minus cos nx upon n square, plus that is the sign of formula, derivative of this term, then minus 2 into minus 1 integral of this term, that is minus sin nx upon n cube, 0 to 2 pi, that is constant, and derivative constant is 0, then 0 into anything 0 then. Now simplify this term first of all, then we go for upper limit and lower limit. Then here pi minus x square into sin nx by n minus 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 3 times minus n, minus 2 pi minus x into cos nx upon n square, minus 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 again 3 times minus n, minus 2 sin nx upon n cube, here 0 to 2 pi. Then we go for upper limit minus lower limit, then 1 upon 4 pi sin 2n pi, then value of sin 2n pi is 0. Then cos 2n pi is 1. Then 0 into anything? 0 minus 2 pi minus 2 pi. Value of cos 2n pi, that is 1. Then 1 pi n square minus sin 2n pi 0 minus 0 sin 0 0 0 into anything? 0 minus 2 pi minus 0 cos 0 1. Then 1 upon n square sin 0 0. Then we just simplified this term. Pi minus 2 pi minus square minus minus plus 2 pi by n square minus minus plus again 2 pi by n square. Then we get 4 pi by n square into 1 upon 4 pi which is cancel out. Then we get an, sorry, here Fourier coefficient of an, that is 1 upon n square. Similarly, we go for bn. Then here formula of bn is equal to integral c to c plus 2 pi. But initial value is 0. Then 0 to 2 pi f of x sin nx dx. Then here 1 upon pi integral 0 to 2 pi f of x, that is our pi minus x by 2 whole square into sin nx dx. Then 2 square 4, then 1 upon 4 pi both side outside the brackets. Then pi minus x square sin nx dx. And according to the dA, that is our u and that is our v. Then 1 upon 4 pi u as it is, derivative in u as it is, integral of v means minus cos nx upon n minus, that is the sign of formula, derivative of u, that is 2 pi minus x into minus 1, integral of this term, then sin nx by n square plus, that is the sign of formula, derivative of this term, then minus 2 into minus 1, minus carry forward, derivative integral of this sign, then minus cos and minus minus plus cos nx upon n cube. Then derivative of 2, that is 0, then constant, then 0 into anything? 0. Then upper limit minus lower limit. First we simplified this term, just then minus pi minus x square cos nx by n minus 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 3 times minus and minus 2 pi minus x into sin nx by n square minus minus plus, that is minus and plus 2 cos nx by n cube 0 to 2 pi. Then upper limit minus lower limit. Then substitute the x as a 2 pi. Then cos 2n pi, that is 1. Then 1 upon 4 pi, here minus sign, pi minus 2 pi, cos 2n pi, that is 1. Then 1 upon n minus sin 2n pi, 0 0 into anything? 0 plus cos 2n pi, that is 1. Then 2 pi n cube, that is our upper limit portion, minus lower limit 0. Substitute 0, then minus pi minus 0 square cos 0 1, then 1 upon n sin 0 0, then 0 into anything? 0 plus 2 cos 0 1, then 2 pi n cube. Then just expand the brackets. Then 1 upon 4 pi as it is, pi minus 2 pi, then minus pi square, then pi square, then above minus n as it is, then pi square by n plus 2 by n cube. Here minus pi square, then minus comes inside the brackets, then minus minus plus pi square by n. This minus comes inside the brackets, then minus 2 by n cube. Then here plus n negative which is cancel out. Similarly positive and negative which is also cancel out. Then 1 upon 4 pi into 0. Then we get 0. That is our Pn. Now substituting the values of a0, an and bn in our formula of Fourier series. That is our Fourier series is f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos nx plus bn sin nx. Substitute the values of a0, an and bn. a0 that is pi square by 6. Then 6 2s are then we get pi square by 12 n equal to 1 to infinite. An that is 1 upon n square cos nx. Bn that is 0. Then 0 into anything 0. That is our Fourier series. That is the infinite series in terms of cosine and sine terms. Here we no need to expand this term. Some of the example we required for the expanding, then that particular example we just expanding. Other than we cannot go for expanding. If you have any doubts regarding this topic, then feel free contact me. Thank you so much for listening me.